of conservation of matter states that matter cannot be created or destroyed. So if you're looking at a chemical reaction, the number of atoms in the reactants is going to equal the number of atoms in the products. Here we have H2O. Okay, this is a molecule of water. We have, remember, hydrogen is going to be in white, the white balloons, and the oxygen is the pink balloon. So this is H2O. Now, in a reaction in which the water is split, one of these hydrogens is actually removed. So in that process, the chemical bond between these two is going to be broken. Here is the example of the chemical reaction. So the before, remember, was water, and the after looks like this. But you do notice that we still have the same number of total atoms, 3. We still have the same number of hydrogen atoms, 2. We still have the same number of oxygen atoms, 1. So this is just a demonstration of the law of conservation of matter. And that really states that matter cannot be created or destroyed. So we can't just create atoms or destroy atoms. That's an example of the law of conservation of matter. So when you look at a reaction, sometimes we call it an equation, a chemical equation, because the number of atoms on the reactant side will equal the number of atoms on the product side. So in some examples you had to do, there were reactions that were unbalanced, that were not correct. So you had to change the coefficients to make them the correct reactions, to make sure you have the same number of atoms on both sides. Another type of reaction, so here is methane. So methane, remember the hydrogen atoms are white, the carbon atoms are black. So this is CH4 right here. This is methane. This is the molecule of oxygen. Water, remember water. This is one of the products of combustion. Water is produced, usually in the form of vapor, steam. And then we have carbon dioxide, 2 actually molecules of carbon dioxide. So 2 molecules of carbon dioxide. Give me a C. Give me an O. Give me an O. What do we have? Carbon dioxide. So here we have carbon dioxide, 2 molecules of carbon dioxide. Remember, carbon is the black, oxygen's pink. So carbon dioxide has 2 oxygen atoms. This is a product from combustion. We have water and we have carbon dioxide. Here is what a model of CH4 would look like. So we have a carbon, black balloons of carbon, and we have 4 white balloons, and those are the hydrogens. 2, remember, it's in the air, it's O2. It's what these subscripts indicate, really, that the atoms are chemically bonded together on both sides. So and they should be the same, obviously. So we're going to look at the reactant side. Remember, reactants, anything in front of the arrow is a reactant. Reactant. So we have, in this, if there is no coefficient, if there's no number here, is 1. There's no number. Okay, so these are 1s. I'm not going to write the 1, but we know it's 1. Here we have carbon. Then we have hydrogen. And we have oxygen. So we have CHO. Over here we also have CHO. Right? They should have the same atoms. Over on this reactant side, we only have 1 carbon. Okay, because it doesn't have, if it doesn't have a subscript, remember a subscript is the number that comes after the symbol, the chemical symbol, and it's below. Okay, so it would be, if there's no subscript, it's a 1. Just like if there's no coefficient, it's a 1. So we're not going to write 1, but we know that's 1. 1 times 1 would be 1. So we have 1 carbon. So now we're going to look at hydrogen. And these reactants, now we're looking at both reactants. Here we have hydrogen. The subscript is 4. So we're going to take 4 times, this is a 1, 1. It's 4 hydrogens. Over here now, O2. You can't change the subscript because these are chemically bonded together. If you separate these, you're making a new substance, a new chemical is being formed, just one oxygen atom. Okay, so this is O2. You can't separate this. You can in a chemical reaction, but when you're balancing the equations, we're just balancing the numbers of molecules in the reactants and products. We're not changing the reaction. Okay, so O2 then, remember? So 2 times 1, 2 oxygens over here. Now let's look at this side, the product side, 1 carbon. Hydrogens. Hydrogens are over here. 2 times 1, right, is 2. Oxygen, now we have oxygen in both of these molecules. So oxygen, 1 over here. Okay, so we have 1 there. And then we have to add what's over here now. This one has a subscript of 2, so it's 2 times 1, which is 2. So we're adding 1 oxygen plus 2 oxygens, which is 3 oxygen. So now we can compare to see if this is a balanced reaction or if it's a balanced equation or not. Both sides have 1 carbon, so that is balanced. That's good. But if we look here, we don't have any balance. If we have 4 hydrogen over here, and we have 2 hydrogens over here, the easiest way to do this is look at which side has the larger number of atoms. So in this case, where if hydrogen has, there's 4 over here, there's 2 here. So now what we're going to have to figure out, what can we multiply times 2 to make it 4? In other words, what number would go here that would create 4 hydrogen atoms? So in other words, what number do you have to multiply times 2 to get 4? We know that's 2. Right? So now we have 4 hydrogens over here, and we have 4 hydrogens over here. Okay, but it might have changed the number of oxygens we have. So now over this side we have 2 oxygen here, and we have 2 oxygen here. So now we have 4 oxygen on this side. On this side we have 2. We really want to figure out what number you're going to multiply times 2 to get 4, which is 2 again. All right, so now this side has 4 oxygen, and they're balanced. I always go back and check though, even if you've done each atom, go back and make sure. So carbons, now let's look. Carbons, we have 1 carbon on this side, we have 1 carbon over here. Hydrogens, we have 4 hydrogens on this side, we have 4 hydrogens over here. Oxygen, we have 4 oxygens on this side, we have 4 oxygens over here. So now this is balanced.